To our next speaker, if I could welcome up John Halpin from the NS3D project. John. Thanks.
Okay, I'm going to be talking about analysis of imagery data and lessons learned from the Insight North Sea 3D project. I work on this project at SAMS with Joe Marlowe and Tom Wilding. Okay, so I'm going to give an outline of the North Sea 3D project. Talk you through our workflow, and then some of the challenges we've found with working with industry ROV footage and how we've overcome those challenges and some of the lessons that we've learned along the way. So the North Sea 3D project, its aim is to significantly improve marine growth biomass estimates for North Sea man-made structures. And the methods are combining photogrammetry, so that's effectively 3D models from photographs, and machine learning or AI. And our data source is industry ROV inspection footage. Our deliverables, so generate benthic biomass estimates for offshore structures using novel 3D imaging techniques, analysing existing industry data. Objective 2 is to train AI algorithms for auto-ID of epifaunal species within footage and combine this with 3D imaging techniques to enable rapid generation of high-resolution faunal models for industry. Sorry, thanks. And finally, objective 3 is to use the outputs from our first two objectives to quantify using a linear model the relationship between biomass and the identity of marine growth with structure type, location, and depth and age. And of course, this requires a large quantity of industry footage over structure type, location, depth, and age. Okay, so that's the key point. We need industry footage to do this. So at the start of the project, we put out a call for industry footage, and thank you. Lots was forthcoming. Many external hard drives were exchanged. It was fun to find out that industry enjoyed working with OneDrive and SharePoint as much as we did. We managed. We've got lots of footage now. Terabytes have been provided. So this is our workflow. So we get the industry footage. So top left, industry footage. We make a 3D model with that. Then we run it through our AI species recognition. So in this case, we've got a section that's covered in Metridium. The AI has found all of the Metridium. We subtract the underlying structure, and that gives us a biovolume. And from that biovolume, we use species-specific conversion factors to go to a biomass. Brilliant. Does it work? Well, yes. Obviously, we can't go to a structure and start kind of surveying it and scraping things off as much as we'd like to. But we used a local reef as a proxy for this. So we surveyed a local reef and then extracted regions in quadrats. We used traditional methods to measure your biomass and compared them with our photogrammetry and machine learning methods. And they compare quite nicely. For most species, it works well. For Metridium, not so much. But the catch is with Metridium, it's able to change its volume by a factor of 1,000 and thus its density. So you would expect this to perhaps not have the same accuracy as the other species. Great. So yeah, we've got this workflow, this pipeline that we know works really, really well. Okay, so just to the first step, making that 3D model. So we use photogrammetry, which is a vision or image-based technique. Okay, so vision, that's going to be limited by visibility, lighting, and resolution in those images. And those are sometimes limited, unfortunately, in this industry footage, which is kind of that's a challenge for us. Okay, so sorry for being so enthusiastic, but this is a really nice bit of industry footage. The lighting is great. It's taken from kind of a good distance away, not too close, not too far away. It's not blurred. I think there's a really good quality camera used here. It's actually a GoPro, but GoPros are good. So fantastic. Wouldn't it be great if it was all like this? Okay, so let's sort of perhaps be a bit more realistic. So the lighting probably isn't set up quite right. So we might have kind of this. The illumination might be off, and because the illumination perhaps isn't what it should be, The camera isn't so good, and it's struggling to keep up. You know, it's kind of on the noise floor, so we've got this noise introduced into the image. The camera, because it's struggling with the lighting, has increased the time it takes to take each image. So now we've got this motion blur. Okay, so we'll deal with that. The camera's quite old, so the resolution isn't good. Industry loves to put these overlays on. So we've lost all this information. The bigger the better. You know, that's, I guess it's very expensive to do, so you really want to put your name on it. That's it, right? It's not going to get any worse. It does. Okay, so the ROV is often there for a purpose. It'll have some tooling. So for many reasons, there's challenges with working with this footage. Lots of the information that could be in the image is lost. So poor lighting, camera quality, wrong settings, the optics perhaps aren't up to it. Tooling, informational overlays, and so on. Even analog camera systems. We've had some stuff that's definitely come off a VHS tape. So another issue is the survey path. So this would be our ideal survey path. So lots of kind of overlapping transects all around the structure, and that kind of helps calibrate our models and produces this nice kind of 360-degree sort of model of the structure, and perhaps some kind of exposed areas on the structure as well that helps us kind of fit the CAD model to the 3D model. But in reality, this happens. So in practice, the ROV is probably there for a reason. It's not looking at the marine growth. It's probably found an anode, and it's going to dwell on that. This single point of view is not ideal for photogrammetry. So the footage is obviously taken from another purpose other than marine growth surveys, and this can obviously introduce a possible bias into the marine growth survey. Another challenge is scaling. So we want to scale these models so that we can actually we're using a volume that has to be scaled. This footage that's taken often isn't scaled inherently. Ideally, we'd have laser pointers there or a stereo camera system, but in practice, we often don't have that. Or in this case, we do have laser pointers, but you can't really see them that well. The arrow's pointing them out, but they're kind of lost in the metridium. So lots of challenges, but we found that, well, there is some excellent footage out there, and from that excellent footage, with thoughtful processing and selection, we can extract the biomass, which is great. So that's a very, kind of a best case model. But yeah, we're very able to do that. So we found some tricks help. So we've been using AI to enhance the colour and sort of restore some of the detail. That's a mixed bag, but it can be very useful. We found a very good trick is to fit the underlying geometry from CAD and engineering drawings. That means we don't need scaling the images. The scaling comes afterwards when we fit the model to the 3D model. For some footage, well, we just can't do photogrammetry, but our machine learning still works really well. So, we can use that to kind of, we can have conversion factors and go from this to a volume. So that's something we can do with footage that perhaps isn't suitable for photogrammetry. The metadata, which is kind of a nuisance, is actually, well, it's metadata, great. So we've found that we can use AI to extract all this metadata, and obviously that tells us where we're surveying and lots of other useful information too, so perhaps the depth, and often this isn't stuff we're given aside from this overlay, so if we can extract it automatically, that's fantastic. We're now working with industry, so amongst others, SSE are on board with us. They're doing a time series, which is amazing because it gives us multiple models that we can overlay and look at how the growth has changed with time. They're using a stereo camera system, which means we can scale our models. We're advising industry, and this obviously has benefits to us and the project and its outcomes and outputs. But it also, many benefits to industry, so it future-proofs their footage, and makes it also more suitable for asset inspection. So the job that they're trying to do in the first place, which is asset inspection, our help helps them with that too, just by improving the footage quality. So we've made an SOP for industry. Please talk to us if you'd like that. It's incredibly easy to follow. We've made it simple, and it's never been easier or cheaper to get good footage. operators can acquire excellent footage with very little extra effort. I guess referring to some of the slides from the previous speakers, there's going to be so many structures. Well, there's so many structures in the sea at the moment, and so many more are going to be installed. We need a tool to rapidly assess what's on these structures, and we have made this tool. We now have an automated workflow to do this. So, in summary, industry footage can be excellent for 3D AI-assisted marine growth estimates, but it can be compromised. With minor changes to data collection, it could all be excellent. Bespoke data collection results in superior models, and our analysis pipeline has automated marine growth assessment for biomass, by volume, and identity. Thank you.
Thank you, John, for an excellent talk. Amazing what you've done with that footage. And I think we're going to move on to Joe now, who's going to drill into some more applications of that footage and where it can go. So over to you, Joe. There's your clicker.
Right. Hi, I'm Joe. I'm a postdoc at SAMS working on the North Sea 3D project with John and Tom. I'm a benthic ecologist, but I'm going to talk about something a little bit different, which is a kind of offshoot from the North Sea 3D project, which is all about creating virtual reality environments to promote the understanding of structures in the marine environment. So everyone in this room knows that when you put a structure in the sea, that's not the end of the story. I spend my days staring at footage like this, which can be really quite beautiful. These structures attract life, whether it is what we call marine growth, so the epibiota living on the structure, which can have incredibly high biomass, high diversity, and certainly adds to the surrounding environment, which is otherwise a soft sediment environment. And indeed, fish and marine predators are all attracted to these environments, and there's elements of invasive species, or something like Lophelia here, huge amounts of endangered species growing on these structures. And so all of us are kind of basically discussing, all right, well, what does this mean for the wider environment? What does it mean for the future of somewhere like the North Sea? In terms of all of the structures we're putting in, and those structures that might well be coming out at some point, or are destined to come out. And so we're kind of reaching a consensus that there are both positive and negative aspects of these structures, and they have to be kind of treated in that way. But what about the public? I don't know about you, but if I talk to anybody about man-made structures in the sea who isn't in this world, then they don't really think about it from one day to the next. And I guess that's because they're out of sight, out of mind. And that's partly why we're putting so much wind structures out in the sea, is because basically it's a lot easier for planning. There's also a lot more wind out there. But if we're going to change how we go about decommissioning, I think we need to bring the public with us. And so they need to be much more aware of the environment that comes with these structures. So in North Sea 3D, we are inherently producing a lot of we deal with a lot of very interesting multimedia that comes from industry ROV footage, but we also produce our own. So we kind of thought we were in a really good position to share this with the public. So this is one of our 3D models, and then it's got the AI overlay, which is all of John's amazing work. So I think it was a couple of years ago now, there was a call for some Insight extended funding for the Phase 2 projects, and we applied based on a number of projects, and one of that was basically outreach. We wanted to go out there and explain to the public the life that is associated with offshore structures, and start to have a dialogue with what should be going on with these in the future, whether the ones that are there should be the OSPAR 98.3, what do people think about it, not really to have an agenda, but to begin a discussion. So one of the first things we did was we went to Dynamic Earth here in Edinburgh for a marine careers showcase for school children. There was about 600 school kids over about 5 hours. It was manic. I would not recommend it. I think John's face kind of here really gives away, yeah. But we had various aspects. We brought our ROV, we bought a massive lump of Lophelia, we had videos showing ROV footage, but the thing that really engaged with the kids was the VR. And the VR at that point was basically just, I think it was actually the model that formed our publication. So it was a dive I did on a reef off Oban, and they loved it. And I think it was more than just beyond, it's technology, they were also interacting with the content of the VR. So this got us thinking, okay, what can we do? And around that time, we were contacted by Rachel Pearl, who, if any of you were here last year, she brought this structure along, which was one of her projects, which is all about using 3D printing to kind of generate, I guess, a nature-inclusive retrospective design on old oil and gas structures. And she was really interested to collaborate with us, and we were interested to collaborate with her. And she works on a master's course at the University of Arts London, at the Central St Martin's campus. That's a narrative environment. It's all about researchers designs and develop stories about science, technology, and society that test the boundaries of space and time. It's not what we normally work with, you know. But it was interesting, very interesting. And we got discussing. And so at Central St Martin's, they have a huge digital element. And so we went about discussing how we could actually develop the VR. And so in the end, we collaborated on a project where 7 of their students worked on it over 6 weeks, where we wanted to basically, our vision was to produce a huge VR model from all of our 3D models of an offshore structure, so people could explore it and to really get a sense of the scale of something like this and the amount of life associated with it. There were some lessons learned along the way. I think we kind of naively thought we could give them a load of the models that we have created and they could directly apply that to their VR world and make a structure which was completely composed of real models of marine growth. That was very much not the case. And I think lessons went the other way as well, that these people had, you know, they don't have a marine ecology background. So the initial models had all kinds of interesting species going around them. So we had little dories going around the North Sea. The visibility was incredible. And bubbles coming out of the seabed at all spaces. But it was a really interesting process for all of us involved. And actually, so what we got down to was, in the end, a structure that was made. The marine growth is very much artificial, but it's a work in process. So here are some images of the VR environment. We've very much got kind of, it's jumping a bit, a zonation from a kind of macroalgal dominated shallow area. These are their renditions of anemones, which it works very well, and some Alcyonium soft corals. It is jumping a bit, but ignore the lines. That's the path of the seal, which I couldn't quite get out of the video. The video is a bit. Doesn't really matter, because actually, if you want to give it a go, we are right outside, and we do have the VR environment, so you can give it a go. But we were really impressed. This was 6 weeks' work from 7 students, not full time, and I think it was giving us a really clear indication of, if we were to progress this technology, where we could go with it. So where we have been taking it is science festivals. So far we went to the Edinburgh Science Festival last month. We had 1,000 visitors in one day. Yeah, I say we, I wasn't there. John was. I was in the Red Sea with Sam's students, so I had a great time. But I am going to Glasgow. But it was really good, actually, because from what I hear, we have obviously the VR, which is very, very interactive with the kids. They're very drawn to that, but their parents are there as well. And so whilst the kids are kind of interacting with the VR and someone's obviously talking to them about the marine life, we're able to interact with the parents. So it's, you know, we're able to kind of educate across all levels. And we will also be going to Glasgow Science Festival, where I will be. And that's in Botanics from the 7th to 8th of June. So if you're interested, please do come along. Hopefully that's me wrapping up, yeah. We will be outside. Please do come along and talk to us. Very interested in hearing what anybody has to say about how else we can use this technology, because at the moment we're obviously using it for outreach, and we can see how it could be used for maybe training ROV pilots in the appropriate kind of courses for photogrammetry surveys, but we think it's got a lot of uses. Oh yeah, I meant to remember that.